If you're preparing for an SAP CPI interview in 2026, you've come to the right place. This video covers the top 20 SAP CPI interview questions and answers that are being asked right now in companies. We've organized these into 4 categories: fresher questions, covering the basics; experienced questions; technical and scenario-based questions. All right, question number 1. What is SAP CPI and how does it differ from SAP PI/PO? It is a cloud-based integration middleware, or what we call an IPaaS, meaning Integration Platform as a Service, built on SAP Business Technology Platform, or SAP BTP. SAP PI/PO is the older on-premise integration platform. You needed to manage your own servers, install the AEX or AAE engine, and handle upgrades yourself. With SAP CPI, SAP handles all the infrastructure. It's fully managed, subscription-based, and scales automatically. In short, SAP CPI is the cloud-native successor to SAP PI/PO, and SAP has officially recommended migrating to CPI as part of their Rise with SAP strategy. Question 2. Explain the architecture of SAP CPI. SAP CPI runs on SAP BTP using a microservices architecture. At its core, there are 2 important nodes. The first is the Tenant Management Node, or TMN. Think of this as the control center. The second is the Runtime Node, which hosts a Java Virtual Machine, or JVM. When you deploy an iFlow, it runs inside this JVM. In between, a load balancer routes incoming traffic to the right runtime nodes for high availability. The TMN reads data written by the runtime nodes to display monitoring information. Question 3. What is an iFlow and what are its key components? An iFlow, or integration flow, is the heart of SAP CPI. It is a graphical model that defines how messages flow from a sender system to a receiver system, including all the transformation, routing, and processing steps in between. Key components: sender and receiver adapters, message routing, mapping steps, deployed packages. Question 4. What adapters are available in SAP CPI? Adapters are the connectors that allow CPI to communicate with external systems. They fall into 4 groups. 1. Synchronous adapters. 2. Asynchronous adapters. 3. SAP-specific adapters. 4. Third-party adapters. Now we move to experienced level. And question 5 is, how do you implement error handling in SAP CPI iFlows? Error handling in CPI is built around the exception subprocess pattern. Inside your iFlow, you add an exception subprocess block that wraps critical processing steps. When an error occurs inside that block, execution jumps to the exception subprocess. There are 3 types of errors you need to handle: system exceptions, network failures, adapter connection timeouts; application exceptions, business logic failures, like data validation errors; timeout exceptions, when the downstream system doesn't respond in time. Inside the exception subprocess, your options are: log the error message using the write step or a Groovy script to capture error details in the MPL. Send an alert notification using the mail adapter, so your operations team gets an immediate email when something fails. Push the failed message to a JMS queue. This is your dead letter channel pattern. Configure retry mechanisms directly on the receiver adapter. You can set the max retry count and the retry interval. Question 6. Explain message mapping versus graphical mapping versus XSLT in CPI. CPI gives you 3 main ways to transform data. Graphical message mapping, the most popular approach. It gives you a split-screen drag-and-drop interface where you map source fields to target fields. XSLT mapping. XSLT stands for Extensible Stylesheet Language Transformations. You write XML-based transformation code. It's extremely powerful for complex namespace handling, conditional output, or heavy structural reorganization. Groovy script step. This is the Swiss Army knife. When neither graphical mapping nor XSLT can handle your requirement, for example, you need to call an external API to look up data or implement complex business rules. You write a Groovy script. Use XSLT when the transformation is purely structural, XML to XML pure data rearrangement. Use Groovy when you need to make HTTP calls, handle conditional logic based on external data, or when processing involves non-XML formats like JSON or CSV. Question 7. What is the difference between synchronous and asynchronous communication in CPI? Synchronous communication means the sender sends a request and waits for the response before it can move on. It's like a phone call. The best analogy, you ask a question, you wait for the answer. In CPI, synchronous communication is done using HTTP, SOAP, or REST adapters with a request-reply pattern. Asynchronous communication means the sender fires a message and moves on. It does not wait for a response. It's like sending an email. The message is processed independently. Question 8. How does security work in SAP CPI? Security in SAP CPI is multi-layered. Let me walk you through each layer. Layer 1, authentication. Basic authentication are username and password. Simple, but only used for non-sensitive internal systems. Layer 2, data encryption. SSL/TLS encrypts all data in transit, meaning data moving over the network is unreadable to anyone intercepting it. Layer 3, authorization. SAP BTP uses role-based access control, RBAC. Key roles include integration developer, can design and deploy iFlows, integration operator, can monitor and manage deployed integrations. Integration viewer, it is read-only access. Layer 4, security material. Never hard-code credentials, passwords, or certificates inside an iFlow. Instead, store them in the CPI Security Material Store, a secure key store. Question 9. What is the Message Processing Log, MPL, and how is it used for monitoring? Every time a message is processed through an iFlow, CPI generates a Message Processing Log, or MPL. This is accessed in the CPI monitoring dashboard under the Operations view. Question 10. Explain Groovy scripting in CPI. Groovy is a JVM-based scripting language, and it's natively supported in CPI via the script step. It has full access to Java libraries, which makes it extremely powerful. How it works. Every Groovy script in CP, I must implement a method called processData that takes a message object as input. That message object is your key to everything. For logging inside Groovy, use the message log object, which gives you add attachment as string to add debug output to the MPL. Question 11. What is the SAP Cloud Connector and why is it needed? The Cloud Connector is a lightweight Java application you install inside your on-premise network. It creates an outbound connection from your internal network to SAP BTP, a secure reverse SSH tunnel. Your firewall is happy because the connection originates from inside the network. CPI then communicates through this tunnel. Question 12. What are JMS queues in CPI? JMS stands for Java Message Service. JMS queues in SAP CPI provide persistent, asynchronous message storage inside the CPI runtime. When a message is written to a JMS queue, it's stored on disk. It won't be lost even if the CPI runtime restarts. This is what makes JMS the foundation of guaranteed delivery. Question 13. Your iFlow fails intermittently due to a downstream system timeout. How do you fix it? When an iFlow fails intermittently due to a downstream system timeout, you approach it in 5 structured steps. Step 1. Diagnose. Open the CPI monitoring dashboard and find the failed message in the Message Processing Log, MPL. Look for a timeout or connection refused exception. Step 2. Immediate fix. Go to the receiver adapter channel, SOAP or HTTP adapter, in your iFlow. Increase the connection timeout and response timeout values. Step 3. Resilient design. Wrap the receiver call inside an exception sub-process. In the exception handler, push the failed message to a JMS queue with a retry delay. Step 4. Alerting. Inside the exception sub-process, add a mail adapter step to send an email notification to your operations team immediately when a timeout occurs. Step 5. Root cause. Resolution. Work with the downstream team to investigate their system's response time. Question 14. Design a CPI integration between SAP S/4, HANA, and Salesforce for order sync. This is a classic hybrid integration scenario. Here is the complete architecture and design. Step 1. Trigger from S/4. HANA. Use the iDoc adapter to receive sales order iDocs, orders 05 from S/4 HANA whenever a new order is created, or use the OData adapter to pull S/4 HANA's sales order API at scheduled intervals. Step 2. Security setup. For Salesforce authentication, configure OAuth 2.0 client credentials flow. Store the Salesforce client ID, client secret, and token URL securely inside the CPI security material store. Never hardcode them in the iFlow. Step 3. Message mapping. Use graphical message mapping to transform the SAP IDOC/ORDERS 05 structure, VBAK for order header, VBAP for line items, into the Salesforce order or opportunity JSON schema. Step 4. Calling Salesforce. Use the HTTP adapter with the Salesforce REST API endpoint to post or patch the order record. Step 5. Monitoring and testing. During development and testing, set the iFlow log level to trace to capture full payloads at every step. Switch to info in production. Question 15. How do you migrate an existing SAP PI/PO interface to SAP CPI? Migrating from SAP PI/PO to CPI is a structured 7-step process. This is called a lift and shift to cloud migration. Step 1. Assessment. Use the SAP Integration Assessment tool, available inside SAP Integration Suite, to inventory all your existing PI/PO interfaces. Step 2. Prioritize. Start your migration with simple interfaces, basic point-to-point, HTTP, or SOAP calls with straightforward mappings. Step 3. Export PI/PO. Artifacts. From the SAP PI/PO Enterprise Services Repository, ESR, export your message types, data types, and message mappings. Step 4. Recreate in CPI. You have 2 options. Manual rebuild. Recreate the iFlow from scratch in CPI's graphical designer, which gives you full control and lets you modernize the design. Step 5. Adapter and mapping. Remapping. During migration, map PI/PO components to their CPI equivalents. Sender/receiver agreements become CPI sender/receiver adapter channels. Always use the integration assessment tool to prioritize, use the migration tool to save time, and always do a parallel run before cutover. Question 16. How do you handle large file processing, for example 100 megabytes CSV, in CPI? Processing large files in SAP CPI requires a streaming and splitting strategy. The biggest risk is memory overflow in the CPI JVM. If you try to load a 100 megabyte file all at once into memory, the iFlow will crash. Step 1. Enable streaming on the adapter, on the SFTP or FTP sender adapter, whichever is reading the file, enable the streaming option. Step 2. Use the splitter step. Add a general splitter step immediately after the file is read. Configure it to split the CSV into smaller chunks, for example, 500 rows per chunk. Step 3. Parallelize with process. Call. For each chunk, use the process call step to invoke a separate child iFlow that handles the actual processing logic, data transformation, mapping, writing to target system. Step 4. Buffer with JMS queues. Between the file reading iFlow, producer, and the processing iFlow, consumer, insert a JMS queue. Step 5. Store output. Externally. Never try to send a large output payload inline through an HTTP response. Question 17. What are externalized parameters and how do you use them? Externalized parameters allow you to configure iFlow settings from outside the iFlow design without redeploying the artifact. In the iFlow designer, instead of typing the URL directly, you type double curly braces around a name. This marks it as an externalized parameter. Question 18. What is value mapping in SAP CPI? Value mapping is a lookup mechanism in CPI that lets you translate code values between different systems. Without value mapping, you'd hard code this logic in a Groovy script or use if-else in graphical mapping. That's messy and hard to maintain. With value mapping, you create a value mapping artifact in your integration package. It's basically a table with columns for source agency, source identifier, source value, target agency, target identifier, and target value. Question 19. Explain content-based routing and multicast in CPI. Content-based routing using the router step is how you implement conditional logic in an iFlow, like if-else branching. The router evaluates conditions sequentially. Each branch has an expression that checks something about the message, an XPath expression on the payload, a header value, or an exchange property. The message is routed to the first branch, whose condition evaluates to true. If no branch matches, it goes to a default branch. And our final question, question 20. How do you implement CI/CD and DevOps for SAP CPI? SAP CPI provides a full REST API, the Design API and Runtime API that lets you automate everything. Here's the end-to-end CI/CD pipeline. Step 1. Source control. Use the CPI Design API to export your integration packages. Get/API/v1/integration packages. Commit the exported artifacts to Git, GitHub, Azure DevOps, GitLab. Step 2. Build pipeline. Use Jenkins, Azure Pipelines, or GitHub Actions. When a developer pushes code to Git, the pipeline automatically imports the package into the QA-CPI tenant using the CPI API. Step 3. Transport to production. Use SAP's Transport Management System, TMS, or the MTAR, Multi-Target Application Format, to promote the artifact from QA to prod with full approval workflows and audit trails. Step 4. Automated testing. Run integration tests using Postman collections, Ready API, or CPI's built-in simulation. Step 5. Rollback. Since everything is in Git with version history, rolling back means redeploying the previous version via the API. Fast and auditable. If this video helped you, please hit the like button. It genuinely helps this content reach more people like you who are preparing for their SAP CPI careers. Subscribe so you don't miss our upcoming videos on SAP Integration Suite, Groovy scripting.